So let us begin with the introduction and modeling to the linear programming. This we will be finishing in 3 lectures. So let us begin with the operations research model. So let us understand what we mean by the model. We are going to take this particular example. In this example, suppose we have a 5-week business plan commitment between Fayetteville and Denver. Between these two cities, we have to fly. Every Monday, we have to fly from Fayetteville and we have to return back on Wednesday. If we are going to buy a round trip ticket, then it is costing $400. But suppose if we buy a ticket that span a weekend, then we are going to get a 20% of a discount. In case if we have to buy just one-way ticket, then we have to pay 75% of the regular price, meaning that 75% of 400. How should you buy the ticket for the 5-week period? Now, as we have understood this particular problem statement, what we can see here is there are multiple alternative way we can buy a ticket for this particular trip. So in this case, when we have multiple ways to buy a ticket, so the first question is, what are the decision alternatives? Decision alternative means what kind of different tickets I can buy, because that will be costing differently. Second is, under what restriction is the decision made? Decision means we have to fly on Monday and come back on Wednesday. So that is a restriction. I cannot just fly on any day. Similarly, if we have different alternatives, suppose we are going to buy different kinds of tickets, then I should have an appropriate objective criterion for evaluating those alternatives. I will be discussing these 3 in detail later. So let us think about what are the alternatives we have. First is, let us buy 5 tickets. That is from city 1 to city 2 and come back for departure on Monday and return back on Wednesday of the same week. So these are the regular tickets I can buy. Or second option is let we have the discount of 20% by booking the ticket in such a way that it should span over weekends. How it can be done? One way to do is we can buy 1 ticket from city 1 to city 2, then 4 ticket as a return ticket. And in this one, we are going to have those weekends and the last ticket from the city 2 to city 1. The third option could be that I can buy from city 1 to 2 and then come back. So the ticket will be spanning from first Monday to the last week and the last week Wednesday. So first week of Monday and last week of Wednesday. And the other tickets, the 4 tickets, as we have discussed in the previous case, those 4 tickets I can buy. Now, what you can see that the first ticket, the return ticket which we have booked, it has so many weekends. And the other 4 tickets, it also has many weekends. So this means that I can get that 20% discount on the ticket. Now suppose we have these 3 alternatives with us. Let us evaluate them. So the first alternative is how much money we are going to pay. Since it's a straightforward, every week we have to buy 5 tickets into 400, it is 2000. Second is we have alternative we have to find the cost of 2. So first trip is a single trip. So that's why 75% of 400. Then we are going to buy 4 tickets which span the weekend. So we have 4 into 0.8 into 400. Plus then again we have a last ticket. If we find the cost, it is 1,880 rupees, $80. Let us look at the third, where all the tickets which we are buying, they all are spanning at least 1 weekend. So in this case, we are going to buy 5 tickets. Since it is spanning the weekend, so 0.8 into 400. So we are going to get a discount. and we'll get a cost of 1,600. Now what we can understand from this, that the different alternatives, like how we are going to buy the ticket, those are giving us different cost. Now in order to analyze those alternatives, what we are deciding is we should have an objective criterion based on the cost. Why? Because at the end, we want to spend less on our tickets. So here, our objective function is minimizing the cost which we are going to spend on the ticket. The decision alternative is what kind of tickets we are buying, as you can see from the three alternatives. And the restriction is we have to go on Monday, come back on Wednesday. Similarly, if we take another problem, which is the simplest problem, we have a wire of L inches. From this particular wire, we are going to make a rectangle such that the area of the rectangle should be minimum. So what could be the alternatives? So we know that in order to make a rectangle, we have to fix width and a height. So width and a height is going to give me a rectangle. So different value of W and H will be giving different alternatives, and correspondingly there will be an area. What could be the restriction? So as we know, the length of the wire is given to us, and from that we have to make a rectangle. So we can say that the perimeter of this rectangle should be equals to the length of the wire. Also, the W and H should be greater than and equals to 0. Now what could be the objective function? As the problem statement says that the rectangular area should be maximum. So we are maximizing the Z, which is equals to W into H, which is nothing but the area of the rectangle. And we know the optimum answer is, or optimum solution for the given problem is when W is equals to H, and that will become the solution for this particular problem. Now what we can understand is that once our mathematical model is ready, then we have to solve it. What we have understood as of now is the decision alternatives. So the decision alternative is also known as decision variables. So these are the standard terms which we use it. So the decision variables that will be changing so that we can calculate what is our objective function. So here our objective function is written in terms of X, Y and other constant parameters. Similarly, we have constraints. Constraint signifies the restriction, and the restriction is we can write in another form of equation, which is G and H. If we are going to make a model, suppose we want to minimize the function subject to, we have two constraints. So one constraint greater than or equals to 0. It can be greater than or equal to, or it can be smaller than type as well. And another constraint is equality constraint, where left hand side equals to the right hand side. And the decision variables, as you can see, X and Y, they are lying between their upper limit and the lower limit. So you remember that in this example, the lower limit is that it should be greater than or equals to 0, but there is no upper limit. Now, what we have to do is once our model is ready, now our task is for searching for a set of decision variables which would minimize or maximize objective function subjected to satisfying constraints in the bound. So we are looking for a XY value so that I will be getting minimum value of F such that the condition of G, condition of H and the bounds on X and Y should satisfy. Now generally what happened that if you look at the figure on the right hand side, here we don't know where is the solution which is going to give me the minimum X and a Y. Let us take this as an optimum solution. Since we don't know, we start with a point, say X. X means it has a certain value X and a certain value Y. So this cross. Now we have some way so that we are going towards this O, which is representing as a optimum solution for the given problem. Now, when we are talking about the solutions, there are different kinds of solutions available here. What are those solutions? First is called feasible solution. A feasible solution is the one which satisfies all the constraints. So if I go back, we have say G constraint, we have H constraint. We can have many constraints. If a solution, the value of X and a Y that is satisfying all the constraints, that particular solution is said to be a feasible solution. Now, what is optimum solution here? A feasible solution which yields the best value of objective function in the entire feasible search space. So I'll talk about what is feasible search space, but what we have to understand is that what is the value of X, Y? So look at the O. So what is the value of X and a Y at O so that our function will be minimum, and that particular solution is an optimum solution. So already an optimum solution is a feasible solution. That's why we write a feasible solution which yields the best value of objective function in the entire feasible search space. What is suboptimal or local optimum solution? So if suppose you take some set of X, Y, and in its neighborhood, this is the optimum solution, means there is no solution which is better than X, Y. So in the close vicinity, so the such solutions are called as suboptimal or the local optimal solutions. Now come to the search space. Why? Because we have used the word called feasible search space. Let us understand what we mean by search space. This particular search space is defined by the constraints and the limits on the variables. So if I go back here, we have the constraints, we have the variable bounds. So the space that is defined by all of them will become our search space. What is feasible search space? So inside this particular search space, if I take any point, the point is always feasible. So you can say inside the feasible search space where a point is always feasible, that we can say is a feasible search space. Now, when we talk about the to get an optimum solution for the given problem, it involves different steps. So first step is what is the need of optimization? So if I refer to the problem where we have a wire length of L and we have to make a rectangle having maximum area, that particular problem I can solve it. Why? I can differentiate with respect to L, with respect to the variables. I can find what is the optimum solution for that. But there are certain problems which are really difficult to solve. When you are going to solve it, you cannot solve it by hand. In that case, we can understand, yes, we need an optimization. So for those kind of a problem, we should use this. Thereafter, if suppose the problem is new, then in that case, we have to first make a problem formulation or the modeling. In this case, we are going to first identify the parameters. So all the parameters related to the problems, we are going to identify it. Among all the parameters, there are parameters which can be sensitive to the problem, can become decision variables. So you remember the decision variables means the X and Y, these are the decision variables, and other variables are other parameters will become the constant parameters. Using the decision variable and constant parameter, we are going to formulate constraints. We are going to formulate objective functions. Then we are going to make a variable bounds on it. If we are working on a new problem, that itself requires 50 to 60% of your effort. Then we have to choose an optimization algorithm. And then we get a solution. Suppose the solution which you get it's not the desirable one. You feel that it is not good. So then we have to again look into the formulation where we can change it. Once you get a desired solution, you can stop your simulations and you can get the optimum solution for the given problem. Now, since in the formulation, it involves decision variables, constraint and objective function, let us discuss them one by one. So when we are talking about decision variables or design variables, first of all, we have to list each and every parameter related to the problem. Thereafter, the parameters which are sensitive to the given problem, those will become the decision variables, and other parameters will become the constant parameters. Once we have identified what this sensitive parameter, basically the decision variables, then we have to identify what types of those decision variable. They are binary, discrete, or real. Binary, it can take like 0 and a 1, decision yes and a no, or on and off. Discrete means it will take some discrete values like 1, 2, 3, 4, say number of gears. These are discrete values. Real number means any value with the decimal places. So when we are going to choose, so first of all, we have to choose few parameters as a design variables. So that thumb rule is important. Why? Because if we have less design variables, then our optimization method can find the optimum solution effectively and quickly. So the question is how we can decide those few parameters will become decision variables. So first is based on the experience of the user, because somebody who is working for a long time can tell you that yes, these are the parameters which are sensitive. There are other methods called minimum variable consideration or sensitivity analysis. The sensitivity analysis we will be discussing later. Then afterwards, once we decided, for example, X and Y could be our decision variable, then we have to put a bound on both of them. Please note that in this particular example, we are taking just 2 variables, but the problem can have multiple variables. It can be 5, 10, or 12. Once the decision variables are decided, we are going to make a constraints. Now what constraints represent here is that is the limit on the resources or a certain physical phenomena. If I refer to the first model where we have to fly on Monday and come back on Wednesday, so that is the restriction. So those restrictions are generally represented as a constraints. Now if you take, suppose you are going to design a beam. Now in this beam, if we are applying a load and the stresses developed in the beam is more than the yield stress, then definitely that beam is going to break. So that is going to be a restriction that it is going to design in such a way that the stress should be less. Similarly, we can think of a deflection as well. Now, when we talk about the constraints, we can have constraint like greater than equal to or smaller than equal to. Any type of a constraint can be there. Such kind of a constraint is called inequality constraint. These constraints are generally encountered in engineering design problems. Then we have equality constraint as h of x is equals to 0. In this constraint, you can see that left hand side is equals to right hand side. So such kind of a constraint we will see in a linear programming. That is our next chapter. Once we have decided the variable bounds and the constraints, now we have to talk about the objective function. Now we have to understand that the objective function can be of minimization type or a maximization type. Now minimization type means suppose we are working in an organization in which we want to minimize the cost of the product. So there our objective function will be designed based on minimization. In another organization, suppose the objective function is we want to maximize the profit of the organization. Now, since the objective has been changed, so we are going to maximize that particular profit. So based on the objective of the organization, either we will be minimizing or maximizing. The interesting part is that the methods, optimization methods that are available in the literature that are generally developed for say minimization. Now question is, if all the methods are developed for minimization and I'm working in an organization in which I want to maximize the profit. What should I do? In this case, we can use the duality principle. What we mean by duality? The minimization of function is equal to minus times of maximization of the function. Let us understand this graphically. So we have this figure here. So above x-axis, we want to minimize the function here. So the function you can see, and when we are minimizing, this is the point where the function is minimum, and this is corresponding to x star. Below the x-axis, we are maximizing minus times of fx. Now you can see this is the function of minus fx. If I'm going to maximize, this is the point, and corresponding values x star. So what we can understand that whether we minimize the fx or maximize the minus times of fx, both the functions will give me the same optimum solution, that is x star. And that is what we call it as a duality principle. So this means that even though my method is solving the minimization problem and I have maximization objective function, I will just multiply by -1 and put it into my algorithm or method to get the optimum solution. There are different OR models. OR stands for Operations Research Model. These models include linear programming, integer programming, dynamic programming, network programming, and nonlinear programming. In this particular course, we will be focusing on linear programming and the network programming. Now the thing is that when we have these OR models, we need some techniques to solve them. Those techniques are called as OR techniques. Now, if suppose we have a problem of that wire, which is converted into the rectangular shape, that particular solution we can find in a closed form. Closed form means I can differentiate them. I can find the optimum solution. But these OR techniques, they do not find solution in a closed form. How they find? They find the solution using algorithm. So what we mean by algorithm? Algorithm includes fixed computational rules that are applied repetitively to the problem. This repetition is called iteration. And what we can expect is in every iteration when these computational rules are applied, the solution is getting closer to the optimum solution. And finally, we should get the optimum solution for the given problem. Now, what we can understand is that since the computational rules have to be applied in every iteration, this task is a tedious and a voluminous. So instead of doing this task by hand, we try to make program and execute on the computer. So that's why these algorithms are executed on the computer to get the optimum solution for the given problem. So with this introduction introduction for this particular course, let me conclude the first session. And in the next session, I will be discussing about the linear programming modeling.